Welcome, everyone. I'm Shah, and this is the Data Entrepreneurs Podcast. I'm super excited today because I'm joined by Louis Serrano, who, if you don't know, is a AI popularizer, educator, scientist. He's done courses with Coursera, deep learning AI on his own. He was at Cohere for a while. He was at Google. So tremendous expertise and knowledge from Louis, and super excited to talk to with you today, Louis. Thanks for joining.
Thank you so much for the invitation, Sean. Big fan of your podcast and all your work. So very, very happy to be here, and also
Wow.
very happy to chat with you and have a fun conversation.
Yeah, because this isn't the first time we've chatted. So Louis was actually the very first guest of the Data Entrepreneurs podcast, but we had some technical difficulties during that first recording, and so we actually lost the recording and weren't able to share it. So Louis has been generous enough to come back again and do it all over again. So last time we talked a lot about his journey, and so we're not gonna go super deep into that all over again. But I do want to kind of give the audience kind of a flavor of your background. So if you don't mind sharing a little bit about your journey
Sure.
in AI data science, like how you got into it and how it's
Sure.
gone for you.
By the way, I'm happy that we had the first try because it was almost like a rehearsal. So it sounds like we're gonna sound like we know, like we're doing it very very quickly and we know everything because we had the chance to rehearse the first time.
Yep, for sure.
Yeah. So I'm an AI person. I like to teach a lot. Is my thing. I am a mathematician originally. I started as a mathematician and I was a research mathematician for a while. And my goal was to be a professor. Somewhere in the process that changed and I got interested in AI and other things. After my postdoc, I sort of switched around and I several reasons. And then I went to Google and I ended up as a machine learning engineer. And I loved it, but I quickly realized that something that happened when I was a researcher and when I was a programmer is that I always converse to teaching. Like I always end up in rants explaining stuff, and not so much in more teaching than in actually doing the stuff. And so at some point I said, okay, maybe I'll just teach for a living. And I thought about going maybe back to academia or teaching somewhere. And then I found that I could teach online when I went to Udacity, and I've pretty much never looked back. I've been in several companies, but I'm always the teaching person in the company.
Yeah.
Here at Apple, different places. Um, and then I have my own projects, which is my YouTube channel, and I wrote the book Grokking Machine Learning, and I sort of
Yeah.
teach at platforms, and basically that's what I do here and there. Always teaching because that's what I enjoy and how I like to learn. So
Yeah.
yeah.
Well, last time we talked, you had just left your role at Cohere, which
Yes.
was a pretty big transition because before that you had the YouTube channel, of course. I think you've had it for like 8 or 9 years at this point,
Yeah.
but um you were at Udacity, you were at Apple, you were at Cohere, so you always had like a full-time gig. You had a salary paying your bills, so
Yeah.
and while you're doing the education stuff. But then when you left Cohere, like the plan was, okay, we're going all in on Serrano Academy on the YouTube channel. So
Yeah.
how's that been going?
Yeah, it's interesting. It was hard decision. Cohere was a wonderful place,
Yeah.
and I was learning a lot. But since I started the YouTube channel, yeah, you're right. 2016 is when it
Okay.
started. It always was secondary, even though it was the thing I loved the most. But it was always on the times that I was free. I would do it
Yeah.
on the weekend, on the evening, and be months before I put a new video. And I had always so many things I wanted to do, and I always said at some point I'm gonna leave and do it. And I actually had the number. I said when I hit 100,000 subscribers, I will do it, and it didn't happen. I just kept
Oh, okay.
in the
Now it's
inertia. But it's always
200,000.
yeah. That's for one. Yeah, it's close. It's getting just past 150, getting to 160.
Yeah.
But yeah, I always, you wake up thinking that, you go to bed thinking that, and then you just have to do it for
Yeah.
the other hours of the day. So at some point I pulled the plug, and I'm very happy. I'm trying to just kind of build a career of it. But
Yeah.
yeah, I love that I'm doing it full time. It's just really fun.
And it's really interesting to hear about you like making that transition and taking the leap because I feel like I went through that as well. So I
Of
was working
course.
full time at Toyota as a data scientist, and
Yeah.
I feel like I knew within 6 months that I wanted to leave, but it still took me like another 6 months to actually like make that transition. So it's just interesting that you'll always come up with good reasons to not like take that leap and like go all in. So
Yeah.
I feel like that's a really common experience for people.
Yeah. 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 But it's good. It's good to make the leap. I feel like sometimes you took the decision a while ago,
Yeah.
and you're just kind of waiting to execute it. But like the decision is taken somewhere, and it's
Yeah.
in the back of your mind, and it's just there. So it's gotta listen to that.
Mhm. And so I think a lot of people like and so I guess we're kind of going off script here a little bit, but a lot of people, I mean, obviously the common grievance or the common reason people don't take the leap is like, how am I going to like how am I going to pay the
Yeah.
bills? How am I going to make money? So like, what's that looked like for you? It's only been like 5, 6 months, but like, how have you been making money?
Yeah, I've been slowly starting to get more sources, and so I'm still kind of finding out.
Yeah.
But there's a few things you can do. I mean, I set up a Patreon, and then I also set up memberships at the YouTube channel. Those are fun because I have one tier that is a monthly meeting with me. Like, I just
Oh,
me and
wow.
all the
That's
members.
cool.
And right now, since it's starting, like, there's a few people, so we get a really fun Zoom call, pretty much personalized.
Mhm.
And yeah, so pretty much those two avenues. And then from the courses you teach, you get some percentage. From the book, I get some percentage.
Oh,
So I'm
nice.
just trying to build. I also, on the side, I do consulting. It's not the main thing I do, but I
Mhm.
do enjoy some things, which is that I learn in a different way. Like, I get to
Yeah.
do hands-on. And then you realize that when you teach, you learn in one way, and when you work, you learn another way. And sometimes I need that one,
Yeah. Yeah.
and so it gives me insights for teaching. Like, oh, if you
Mm.
run into this problem, do this. So yeah, it's pretty much building an ecosystem. But which I think you've gone through the same thing, and maybe I'll catch you offline and ask you a bunch of ideas. But yeah, it's pretty much building a portfolio, right? Like,
Yeah.
yeah,
And I feel like that was so much the journey for me as well. Like I left Toyota and I had all these ideas like, oh, I'm just going to freelance because that's how I did in the past.
yeah.
But at one point it was like I actually made a video about this. I had like 9 different revenue sources in that first year, but
Wow.
that's usually not a good thing. You know what I mean? Because that means like none of those 9 things like have actually worked. You're not getting like significant traction that
Okay.
you can kind of like pour all your energy into that like top one revenue source that
Yeah.
you can make like that 10 grand a month or more that you're making
Yeah.
as like a data scientist or a technical professional at one of these companies. So I wanted to kind of double click on you talking about consulting and like that being another way for you to learn. So it sounded like diversifying your learning styles and the ways you learn is like important to you. So like, what does
Yeah.
that look like? How do you learn? Because I feel like so many people learn by watching your videos. Like, whose videos do you watch, and like, what's your strategy?
I do have some places I go to. I have Jay Alamar, for example. I watch his
Hmm.
videos. Well, a friend of mine, so I talk to him and I ask him questions. But so Jay, Josh Starm's pretty good too. StatQuest, Three Blue One Brown. Everybody watches Three Blue One Brown.
Yep.
He's nice. There's a bunch of really good channels. Veritasium, like, there's a bunch of really good
Yeah.
stuff that I like to learn from. But basically, I have a weird way of learning that definitely was not built for school
Mm.
because I was terrible in school. Which is that I don't do theoretical stuff very well. Like, if you put a formula in front of me, it could be an easy formula, and I don't know what's happening until I
Mm.
put some numbers on it,
Okay.
until I give a fun example, like a
Hmm.
quirky with ducks in a row or something like that. And that's how I explain stuff to me. For my whole life, it's been like that. So I'm very slow. That's why I'm so slow at doing things, right?
Mm.
Like, coding is very slow. Like,
Yeah.
researching is I'm slow because I'm turning everything into my own language.
Yeah.
Um, and so when I started sharing that with others, it went really well because turns out I'm not the only one. Sometimes takes a while understanding. So I that's when I started seeing that what I thought was stupidity, because all my childhood, if you're a little slower, it was just the kid's dumb,
Right.
right?
Right.
So I that it was a strength for teaching,
Mm-hmm.
you know. But basically, yeah, the way I learn, I have a new thing to learn, I just I start thinking of the most easiest example, and how I would explain this to like somebody who knows no math.
Yeah.
So for example, if it's an image, I do a 2 by 2 grid with 4 numbers from 0 to 1. So a gray scale 2 by 2 image, and if I can explain how to understand that image, or generate that image, or build that neural network for that image, then I get it. If
Yeah.
it's text, then I have like an alphabet with 3 or 4 words that you make sentences,
Yeah.
like
Yeah.
Jane saw Tom and Tom saw Spot, like that kind of stuff, that kind of thing. And if I can explain it with that little uh, 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 language, then I can explain, for everyone. So I always try to bring it up to that. And also like context switching, right? Like
Mm-hmm.
sometimes you're a physicist, sometimes you can explain something with physics, like things that are falling or something,
Mm-hmm.
or with other examples like that you can.
Yeah.
So I just get obsessed. Like I start thinking about it and thinking about it and thinking about it and drawing stuff. And lately I've been using language models. Like I've used ChatGPT a lot. Like
Mm-hmm.
I just start asking it questions, and it starts figuring out how I think. So I go, okay, I want this example with a dog and a cat. Now, state space model, what is it? And then it just keeps it starts picking up how I think, and I have
Yeah.
to
Nice.
help it a lot.
Mm-hmm.
But I feel like it's kind of like talking to someone. So I go, okay,
Right.
what about this explanation? If I were to say this, and it goes,
Mm-hmm.
well, yeah, but you're missing this. Okay, what
Yep.
if I say that? And I find that it's a good way to. It's like somebody who
Right.
thinks they can train to think like me, and so yeah. But I'm basically, I don't have a system. I'm just always thinking about something, scribbling, talking to people, telling, hey, what about this explanation? What about this? Do you think this makes sense, etc.? And that's kind of how I learn. Yeah,
No, I love that. Using ChatGPT as a brainstorming partner. I definitely do the same thing with ChatGPT, and also my fiance, who is not
mm.
technical at all.
Yeah,
And I'm not sure what your wife's background is. I don't know if she has a AI background, but I feel like explaining these things to people who are non-technical
yeah.
is really helpful, because that's like a good heuristic.
Yeah, so my wife does a lot of marketing stuff, and also like emotional
Okay.
intelligence stuff. Like she's
Yeah.
also doing like a big portfolio of things. And it's funny, we use the same Chat GPT because I have the paid version. So sometimes she uses, sometimes I use it, and so it's a bit of a mess. One day she was
Yeah.
asking it, okay, what are things that describe me? And it was like half me, half her, right? Like
Uh-huh.
you like AI and also emotional intelligence. And so I put the following prompt. I said, this account is used by 2 people. Can you
Mm.
cluster them and figure out
Oh,
which are
nice.
the characters? And it was person 1 described me exactly, person 2 described her exactly. So now when we ask, I just go, hi, I'm person 1, and I need you to help me explain
Oh, that's really
this.
cool.
Yeah,
Yeah, I like that. And then another thing you were mentioning was kind of using these like analogies to explain topics. And I've always been fascinated by analogies of like mapping something that is unknown to something that is known. And of course, no analogy is perfect, but it's like one of the most powerful ways to convey like a brand new idea.
yeah,
And also, I when that example you gave of the image, it's like, okay, what's an image? You just have 4 numbers and just start explaining it. I feel like now it's so easy because technology has gotten so abstract. With you can just get a Python library and everything is abstracted. It's just like a one line of code.
yeah.
It's easy to get disconnected from like how things actually work. So I feel like you know that's probably why people resonate with your teaching style, is because you kind of boil it down to the simplest, but it's like you're getting to the essence of the concept, like the thing that you need to know.
Thank you. Yeah, I know. I definitely enjoy that, and I feel like I have a bell that rings in my head when I hit the essence, and I don't know how to
Oh,
explain
nice.
when it does, but I'm like somewhere, and then I'm thinking, and then I'm
Hmm.
thinking, and then suddenly like ping, and I'm like, oh
Yeah.
yes, I have it. Okay, and then I may still have to do a lot of work and stuff, but like there's always a click that I get, and I try to make it like clear in the video. But yeah, sometimes there's like, I'm always waiting for that sort of a eureka moment.
So is that clarity, that kind of eureka moment, is that kind of like what you love about teaching? Or is it something else, or are there many things?
It's everything. I feel like a vocation is when you can align two things. Actually,
Mhm.
that I've been seeing a lot of ikigai lately, but there's
Okay.
aligning a few more things. But let's bring it down to two. If you can align what you like doing for yourself, like what you
Mhm.
just do for fun, like a crossword puzzle or a Sudoku or running outside or some cooking, something that you like and you would do even if nobody finds out and it's just for you, and that. And then also, if you can align that to what you want for the world or how you feel like you can make a positive impact, how you feel like you can help others, if you can align those two things, then you hit jackpot, right?
Yeah.
And so I feel like with teaching, it means a lot to me that I help people. It means a lot to me that I get messages and, this was
Hmm.
helpful and stuff like that,
Yeah.
coming from me who had a very hard time learning, and
Yep.
a very hard time with traditional education. Someone saying that, that really helped. Sometimes people send me a project that they did for the community or something, and we did this because I understood something from your video, and that really touches my heart. So I definitely that, empowering people, like just saying, hey, it's not that you're not dumb, it's just you've been taught wrong,
Yeah.
and making them feel powerful and intelligent, and saying, hey, definitely there's nothing you cannot understand, and there's nothing you cannot do. So that means a lot to me. And so having those two things, basically the fact that I would still make the videos if nobody watches them because I enjoy them,
Hmm.
and the fact that they help, I think it's, to me, is bliss.
Yeah, and I find that as well, and I feel like that was, I recently launched a course that I'm gonna ask for your advice on,
Yeah,
but uh, that was one of the things. It was, what do I enjoy doing that is also valuable to other people, like finding that alignment. Because you know, the first 6 months, 8 months of my journey, I was pursuing like consulting,
yeah,
and that was something that you can definitely make a lot of money doing, but it
yeah.
just wasn't something that I was getting a whole lot of fulfillment from. So I
Mhm.
decided to walk away from that. But the YouTube videos, I've always enjoyed making videos, and like
Yeah,
that's why I started the channel, um, like in the first place, like without any prospect of making any money from it.
yeah.
So I think that
Mm.
alignment is super important. Oh,
And
sorry,
by
what were
the
you gonna
way, a
say?
shout out here is that you have a course called AI Builders Bootcamp on Maven launching tomorrow. So anybody
Yeah,
watching this, definitely check it out.
yeah,
Please put the link in the comments, because it's a course, I can do the promotion because it's not shameless if I do it, right?
yeah. It's not
And so I,
shameless.
definitely, you're doing it with, hands-on, right? Like everything is builder, and so, that's a very useful tool for people. Many people in AI learn the sort of the hands-on way,
Right,
and
right.
you gotta, because sometimes you know the theoretical stuff, but you gotta have the tool and build something. So super highly recommended for the viewers. AI Builders Bootcamp on Maven.
Thank you for the
Yeah,
shout out. Well, my first lecture's tomorrow, like you're saying, it's launching
nice.
tomorrow. Like any advice? I know you've taught like countless courses and given countless lectures at this point. Um,
Yeah.
yeah, what
Uh,
how can I
cool.
avoid failure, complete
You
failure
will
on
not
day
avoid
one?
failure because you make great content. So there's no chance for that. I mean, I think, I like to teach the course that I would have received when I was learning something. So I
Yeah.
like to teach to that because that's my data point, me, right?
Hmm.
So it so I like that. Like what would keep me awake for an hour, and that's
Yeah.
such a challenge that I have to pretty much do jumping jacks and, stuff like that. So that think of what you would like to hear.
Yeah.
uh and I guess another thing, I do this sort of weird, non-orthodox thing. When I teach a course, the first thing people ask me is, okay, what's your target student? And I know that's a very fair question. As I know that's a good question. I never know how to answer that question. I so I kind of go to, well, but in reality, like, I like to cater to as many as possible,
Yeah.
you know And I obviously there's barriers. At some point, you can't teach the whole world with a piece of material. But if you put the barriers before, then you stick to those barriers. If you don't put them and you just kind of let it flow, you have an idea
Yep.
of who you want to teach. But then you try to expand it as much as possible. And then, for example, you say, okay, now I need them to know this, what a matrix is. Okay, I just take 5 seconds to show them one. And then in the other end, oh, there's a super expert here. Okay, maybe they would like to see
Yeah.
this formula or that.
Right.
And so
Right.
if you expand it as much, and then at the end you say, okay, I got from here to here, right? This is the perfect student that I want,
Mm.
But if you aim for as high as possible, this is not something that's standard for educators, but they normally say put a huge effort into defining your persona and your student. And I respect that. Works for the people that works, but for me, I just try to go as wide as possible, so
Yeah.
like I like to think that you have a lot of instruments there. I feel like you're a musician, and I feel like music, I'm jealous of music because music does it well, right? Like music, you can go to a concert
Yeah.
and you can play the piano, you can play some music, and a baby can be there, or somebody who don't know music, or Mozart can be there, and everybody will understand it in a different way. The
Right.
baby would enjoy it, or the
Yeah.
person who
Yeah.
doesn't know music will enjoy it, and then Mozart would capture a bunch of things that are there.
Mm-hmm.
So if you can do that, so that the
Yeah.
expert captures a bunch of things, but the beginner
Right.
understands it the way you explain it, then that's successful. So yeah, that's kind of my
No,
advice. I've seen your content's very good, so
I feel that's like a really deep statement. It's you kind of explain something in such a way that the audience will kind of get value from it no matter what their
yeah,
background is, you know? And I find that some of the best like science educators or, like communicators and popularizers, kind of like
yeah,
yourselves, like that's what they're able to do. They're able to kind of say a line, it makes sense to the layman, but also the expert is
yeah,
like, oh, I actually, that's a really good way of explaining it, or I hadn't thought of it that way. I had never made that analogy or thought of
yeah.
that metaphor. um yeah, I guess that's the goal of being a good educator, just kind of saying it in a way that everyone in the world understands, but they all kind of get something slightly different out of it.
Get some insight. Yeah, that's what I try. So yeah,
So, last time we talked a lot about your journey. We talked about YouTube and education and stuff like that. But now I want to transition the conversation more to like, I don't know, big picture, maybe even more philosophical things, because we're in a really interesting time right now. It feels like yet another technological revolution. We had the industrial revolution, then we had the computer revolution, internet revolution. Now we're seeing something happening with AI. It seems like we're, going through another one of these revolutions.
hmm
And I guess that was especially highlighted recently when the Nobel Prizes for physics and chemistry went to AI researchers. And so, I'm really curious to get your take as someone with a, math PhD. So you're very comfortable with like the fundamental sciences and the math, but also very comfortable with the AI. So like, what do you see as the relationship between like fundamental science and AI?
yeah, that's a great question, and I think it's huge about the Nobel Prizes. And I kind of want to ask that question to a physicist as well, right? Like, I'd love to hear what you think. But yeah, I mean, I feel like the connections are very interesting and very deep, right? Because let's talk about like Hopfield and Jeff Hinton, right? They connected some things that are not necessarily don't look similar, right? So the neuroscience thing is, if you do a lot of things together, then areas of the brain get stronger. And I'm no neuroscientist, but I think so it could be brain cells that get stronger connections, or it could be parts. I don't know. But the fact is, if every time you drink a coffee, you also eat a donut, there's a strong
Yeah.
connection. When you drink a coffee, you be like, where's my donut, right? Like that's how the brain works. That's one thing. And the other one is in physics, right? Like if you have a state, if you have a bunch of stuff going on, particles at the thing, that it can be in many states, it tends to go to the state with less energy. Like the state with less energy is the one with highest
Right.
probability. And if you let things go, they will cool down, right? Like if a ball is like this all over the place where you'll find it after a while is wherever the bottom place, right? Or if I have a bunch of magnets repelling and attracting, and I let them there, they're going to flip, flop, 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 and end up in the state where there's the least amount of repelling, right? Like those things, those two notions don't look alike. They don't sound similar, but they are exactly what builds a neural network, right? Like Hopfield networks, for example, is the grandfather of neural networks. Is the simplest network you can have, or that I can imagine. It's basically that, right? Like you have in the brain, if you do things together, they get closer. Like walking, if I move my right leg, then the left leg moves. That's not present in babies. That's why they can't walk. But when they wobble enough, those regions of the brain get close, and they can do one and then the other one. Or like I don't know, a tennis player has this movement to perfection because they do it so much that the regions in the brain that do it get close. Or a pianist will have the region of the visual and the hearing and the fingers or something very well connected. And a Hopfield network is that, right? Like in a Hopfield network, you have a bunch of features, like a bunch of dots, and two dots, if each one represents some feature of your data, some column of your data set. And if those columns appear a lot in common, if those features appear a lot in common, there's a strong connection between the edges. And every time they appear, the connection gets stronger. And if they never appear together, there's a weak connection, right? So like language, if there's a note for each word and two words appear together in a lot of sentences, then they get stronger and stronger and stronger and stronger. And if not, they get weaker. So that's exactly Hopfield network, right?
Yeah.
And then training it is the physics part, right? Like if you come up with an energy, cook up a formula for energy that's very high for a network that is not where the labels are not good. For example, the coffee's here and the donuts here, and you do them a lot, but the edge is very weak, then that's a state of high energy. And you want to bring it, if you do the training correctly by sort of pretending to cool it down, then you get the network with the edges that makes the most sense, right? That's the equivalent of the ball falling down and resting at a spot, or the magnets figuring out how to flip to get into the most peaceful configuration, right? So when you connect those two, you get a Hopfield network, right? And then you can do more stuff, right? Because Hopfield networks only have two correlations between two things, but you can have a correlation between 3 or 4 or 10. That's where RBMs come in, right? So that's Jeff Hinton, right? So you can have, if I can't figure out a correlation between 3 things, like if I drink a coffee, I always eat a donut, but if I do those, I never go to the gym. So there's a 3-way correlation with a negative and a positive. Well, then you have a bunch of hidden nodes on top that capture these correlations. So so if it was language and I have all the words here, I have all the topics here. And so, for example, if one is weather and the other one is sports, when weather lights up, then all the words corresponding to weather light up. So an RBM is like an enhancement of a Hopfield network. But basically, when you put the neuroscience, the brain sort of simplification and the physics, then you get AI, right? And I think that's what they did, and that's just absolutely fascinating. So
I'm really glad that you kind of gave that explanation, because I haven't read up on Hopfield networks and very limited reading on random Boltzmann machines. So I got to watch your video for sure. And anyone else who was kind of like, wait, what is this guy talking about for the past few minutes? Definitely check out his video on Hopfield networks, where he kind of breaks down behind the Nobel Prize. But so it's like the two key insights. It's like, okay, we're observing these two things from nature. One, neurons that fire together wire together, and two, this optimization principle for whatever reason nature loves to optimize. It loves to minimize energy, loves to maximize entropy, like whatever, likes to minimize action. And so bringing those things together created, these early versions of the neural networks that we see today. So that's super cool. Another thing that's really interesting is that when you spend a little bit of time in AI and machine learning, you start bumping into people like you and I. So I have a physics PhD, you have a math PhD. I've met people with like neuroscience masters, data science masters. So it's a lot of like educated people, like a lot of people that come from like a research background or like a hardcore science background. And then so I guess we were talking about like this relationship from like a conceptual perspective. But it also seems to be from like a social perspective, like people that are into fundamental science for whatever reason also seem to be into AI. Like, why do you think that is?
Yeah, that's interesting, right? I definitely have met a lot of people who are from different sciences, whether it's like social or like something technical.
Yeah.
A lot of different like psychologists I've met that go into AI, and I think that that's beautiful
Mm-hmm.
because it's sort of new ideas and a lot of facets to the field, right? You're looking at something from different perspectives and you gain more dimensions, right? Like if we all look at it from one side, we see this part, but if you have people from all the angles, you see a lot more. So a lot of things people catch that I don't catch. Like I look at it the math
Yep.
way and I catch a few things and I'm like, oh, this space something blah blah blah, and then the person who does something else, the chemist sees bonds, and
Yeah.
then the physicist sees other things, and the psychologists and sociologists see behavior of humans
Mm-hmm.
exemplified in a machine learning model. So I find that beautiful. I think the reason we get drawn to it is because we're just curious. Like people who are curious are
Yeah.
that never stops, right?
Mm-hmm.
And I think AI kind of encompasses a lot of those things, because if
Yeah.
you're trying to get the computer to think like a human in some way, then you need all kinds of humans, right?
Yeah.
You don't want
Yeah. Yeah.
only one kind. And so anybody comes and sort of injects their own way
Mm-hmm.
of understanding this and of giving that to the computer. Like all this AI algorithms are teaching something to the computer, how we make decisions, and everybody makes decisions in a different way.
Yeah.
So yeah, I mean, I love that, and I'm glad that it's a field that has a lot of variety.
Yeah, I really like that as well. Not just from like, you work in a data science team or machine learning team and you just get to learn all different things because people are from all different types of backgrounds. But yeah, that insight that like even if you look at the algorithms in the field and the approaches and techniques that you'll learn, it's like such a wide range of inspirations, like things from math, of course, but physics,
Mhm.
biology, and neuroscience.
Yeah.
So it's I think ultimately that diversity is probably the biggest, like AI being multidisciplinary is probably one of the biggest driving forces behind it.
Yeah.
um yeah, go ahead.
Definitely. Like that connection between sort of neuroscience and physics requires somebody who knows one and somebody who knows the
Exactly.
other one. It would
Yeah,
never
yeah,
come up if only you have one kind of person, right? So
yeah.
those things come out pretty beautifully.
And I feel like that's perfect for someone like me, that I'm curious in so many different things, like what you're saying, like
Hmm.
just curious people, like they don't it's not that, oh, I only do proofs. Like don't talk to me if it doesn't have a theorem in it, don't talk to me about
Yeah.
it.
I
Um
know people.
but it's like for people who are interested in multiple fields and are more
Yeah.
interdisciplinary. Yeah, I that's really
Yeah.
interesting.
And I think that's our nature, I think for many years humans uh just sort of focused on one thing, maybe because it's
Hmm.
more productive for whoever. But I
Hmm.
think we're not like that. We didn't evolve by only doing one thing. We evolved by being
Right.
aware of all the things. And I mean, in the Renaissance, like people did a lot of stuff, like
Yeah.
peop now we just like, oh, no, I'm sorry, I do this one thing, don't talk to me
Yeah.
about anything else. And even within fields, like in math, some people are
Hmm.
like, no, I do this kind of math, don't
Yeah. Yeah. Yeah.
bring that. I feel like we're not like that. We're maybe we can
Mm.
specialize in the things we like, but I think our nature is more like, curious about
Right.
many other things. So I like to expand as much as possible. I think it's healthy for the brain, and I think it's healthy for the society.
Yeah, for sure.
Yeah.
So we will be taking audience questions. So for those of you watching and you guys got questions for Lewis, feel free to start dropping them in the chat. I got a couple questions queued up here. So while the questions come in, we'll just keep the conversation going.
Sounds good.
Um, so, like I was saying earlier with like these technological innovations, it I feel like the most striking observation is that like the duration between, let's say, like the steam engine and the computer was like, I don't know, a couple hundred years, but then like to go from the computer to the internet was just like 50 years, and then to go from the internet to deep neural networks was just a couple decades. So it's like
Yeah.
these like world changing innovations, like they're happening faster and faster. And so, like, is there a limit to this? We're just speculating now. You know what I mean? Like, is it possible for innovations to happen every hour? Like, is there like some fundamental limit to the pace of innovation? And then, like, do you think AI is going to play a fundamental role in that?
I mean, yeah, I don't know. I mean, there's a Moore's law, right, which only takes care of the physical part,
Yeah.
which has a limit, right? Because at some point things get so small or so big that just don't the physics doesn't allow it. So that one for sure will hit a wall. In terms of innovation, yeah, I mean, it goes so fast that we're now having to turn into malleable people that change careers every few years because it's impossible to do what our grandparents or parents did, which is do one thing for the rest of their life.
Yeah.
Nothing. We don't. What are we going to be talking about in 5 years? Doesn't exist right now, right? I find that with AI innovation, there is innovation, but actually a lot of like new things don't come up so often, except like computers get bigger, there's more data. Now everything produces data, so there's just a lot more data, a lot more computing power, and a lot of the innovation is just make them bigger or figure out a small way to connect there that slightly different architecture. But neural networks are still, I mean, ChatGPT is a huge neural network, which exists for a long time. Attention mechanism is something new. I feel like that was innovative, and if I were to say like that, theoretical innovations that made it jump, that one would be it. But I feel like those don't happen that often. Like normally what happens is you optimize things, you make them a little better. Like it's pretty continuous. There's no the big jumps happen are more spaced out. But yeah, I mean it makes me wonder what's what's gonna happen, and if every few minutes there's gonna be something huge. I feel like things also take some time, right? Like they take some time to adopt, right? The internet came and it took us a while to start getting used to, because now it's humans the ones that have to rewire ourselves, right? Like to start making transactions, bank transactions in the internet. It took a while. Like if you tell me when the internet started that I was going to do banking there, I would have been like never. That's for chatting and for watching images. And so like you take a while. So the same thing with AI. Like in order to get people to start using it for everything, it takes a lot of rewiring, and sometimes even takes a generational change. Like sometimes it just takes new people who grow up with that technology. So I think maybe that bottleneck is how quickly can humans adapt to things, right?
Well, I could, conceivably, like if just like now, basically everyone uses the internet, and then let's say in the next 5-10 years, basically everyone is using AI in some capacity, and we've and maybe at some point we have these neural link chips in our brains. So like the human limitations just get smaller and smaller because we've kind of offloaded so much of our daily work and operations to digital systems. Then maybe the pace of innovation can really skyrocket and go off to the races because we just have AIs doing things for us.
Yeah, maybe the innovation can also come from AI. Like we'll be able to take a driver's seat of saying, okay, I want to make this scientific innovation, and I can give the big ideas, and the computer can take care of stuff that would take me years to figure out, So I feel like it almost adds on itself, right? Like the innovations help find more innovations.
So that's another fundamental question that a lot of people have been asking since ChatGPT was released, but which is, are these AI systems capable of extrapolation rather than just interpolation? ChatGPT is so magical because it's basically trained on all of human knowledge. But can it predict something? Can it generate something beyond human knowledge? Like, so can it make those scientific innovations? Like, what's your sense about that?
I think about that a lot, and I ask the question: what are humans doing when they come up with an innovation? Are we extrapolating or interpolating? Like, are we really good at taking stuff that exists and finding points in between and connecting to things that already exist? How often do we come up with something outside? Right? If this is human knowledge, like how often do we come up with fill in dots, and how often do we actually find a dot outside? and I don't know the answers. I don't know. I think definitely AI can fill in dots and connect things faster than us. So a lot of innovations it'll be able to do. When it comes to new ideas, I also wonder how much are these new ideas combining two things. Like, for example, the brilliant idea of combining the ideas of neuroscience and physics to get a neural network. That's a brilliant idea. With this connecting two things we already know, right? Like, it's connecting. So in principle, it's joining two things. And if you had a lot of computing power to try connecting a bunch of pairs of things until you get something, maybe a computer could get it. Not to discredit the geniuses that came up with it, right? But I'm saying that there's a lot of things that I think AI can do. For example, in math, right? Like, what is proving a theorem? You have a bunch of building blocks, which are the axioms, are the things that we believe are true, but are so simple that we can't prove them. So we just kind of take them for granted. We say, okay, I'm going to pretend that this is true. And then from there, I have a basis of axioms, and then I start making little lemmas by combining a few of them. And then I make more theorems by combining a few of these, and I'm kind of building. And then I have a conjecture that's way up here, and I say, I want to prove this. And basically, you have to kind of put building blocks. And I mean, that's kind of a game. I'm oversimplifying it. But if a computer can play Go, which has more state positions than atoms in the known universe, I don't see why it can't play math. I don't see, and I may be wrong, I'm just speculating here, but I don't see why it can't prove a bunch of stuff. It may not know, for example, what direction to take, right? Like, you want to take math in this direction, you want to, connect. It may not know that, and that may be what researchers need to focus on, and that may be what takes the mind of a researcher. That may be the extrapolation you're talking about. But in terms of, like, interpolation can get pretty far, because a lot of research is combining building blocks. It's playing a game of combining building blocks to get something to a place where we want to get, right?
And so I feel like oh, sorry, go ahead.
No, go ahead.
I was gonna say, I feel like another version of this question, which is kind of cheeky, which is overfitting a problem if your training data is all of human knowledge, which is kind of like with the ChatGPT.
Absolutely. I mean, I think overfitting. I mean, I think even humans overfit a lot, right? Like, any bias that we have is overfitting, because it's like you saw a particular feature on someone, and you saw a particular behavior, and then you will forever combine that feature with that behavior if you can get advantage of it. And that's overfitting, right? That's superstition. Sometimes it's overfitting. If every time I do something else happens, I join them together, but it's not true, right? Like, if if every time we have this thing, Colombia, if you walk underneath stairs, you have bad luck. I don't know how that started, but maybe it happened to someone 3 times, and they said, generalization, overfitting for the rest of us. And then we train with this, we get that information and train our networks like that. But I mean, I think we have overfitting in humans, and all the data that is used for training models comes from humans. So of course that overfitting comes in, and we've seen huge problems with biased models, racial bias, gender bias, and all kind of bias that are really hard to extract and really hard to remove, because they come from humans that are just as bad. So it inherits all our stuff. And even without that, like, I mean, who tells me that a huge neural network is not gonna, like, maybe pick up on a correlation that's not there, but it just happens to coincide a lot, and think that that's a correlation. So it very much can happen. I mean, the probability that two variables that are not correlated in real life don't, in some data set, appear correlated, you're as a scientist, like, this is pretty much zero, right? So yes, I'm pretty sure there's the bias come from human, and the biases that model gets for free are huge. So yes, definitely yes, overfeeding. Big yes.
So we got a couple audience questions. So one is coming in from Ravi. He's asking for your thoughts on quantum computers. Do you think they'll be useful anytime soon?
Hi, Ravi. Great question. Everybody wonders that, like in quantum computing, everybody wonders that. I don't know. Um, yeah, people are excited. I mean, I think they are closer and closer. The physical limitations are not easy. Um, and the limitations between they actually you can handle stuff in quantum world and you can handle stuff in real world, but bringing it from
Mhm.
one to the other is hard. Getting an environment that you can uh, that is isolated enough that it doesn't get observed and can do its thing, and then also a way to observe stuff from there, it's almost a contradiction, right? So not easy, but I'm excited. I think I'd be very surprised if they don't, if we live our life and quantum computers never pick up. I feel like they have a good chance, and the stuff that's done theoretically is wonderful. So I kind of hope that they that they start working well. You see a lot of advances, like you get machines with a lot of qubits now, so I feel like there's a chance.
Yeah, I feel like I took one quantum computing course as an undergrad, and the only thing I remember is we'll have to change how we encrypt credit card transactions or
Yes.
credit card numbers or something like that. So,
Yeah,
uh,
they can factor numbers. I'm actually getting a series of videos on that. So it's
oh, nice. Okay.
factoring big numbers, Shor's algorithm. Yeah.
Yep. All right, so that's something to keep your eye out for, everyone in the audience. So this is another question we got from our Discord community.
Uh-huh.
You were talking about your time as a machine learning engineer at Google. So this guy was asking about, let's see, you know, putting AI into production. I guess not much of a question here, but maybe just like
The
your
stuff I
thoughts and
know the
advice.
least. That's the weakest spot. You hit me on my Achilles heel. No, yeah, production. I don't know so much about putting stuff in production. So is there a specific question, like, or just in general? What are thoughts or?
Yeah, I guess they said one thing that goes underreported is putting AI into production. Is it too late to ask him about that? Um,
No, it's not too late. I just don't know that much about it. Yeah, I think like definitely a lot of cloud computing is now used, right? Like I would say there's a lot of tools that are already made, and so every time I think it's more about how to use what particular tool, right? Like you don't buy your own servers anymore. Now you just go and use it,
mhm.
AWS or Google Cloud or Azure or something. So I feel like the same thing with tools. Tools are getting like more democratized, and so my first thought would be to just go and look at what it's already existing, what's done, what's not to reinvent the wheel, and then from there just put the pieces together. Yeah.
Yeah, I feel like a lot of people, there's like production has kind of become a buzzword now, and
Yeah.
people look to these like massive tech companies and say, "Oh, the way they do it is the way I should do it," even though they're like a small, little scrappy startup, or maybe they're just like a small business trying to, you know, create some like small SaaS feature or like upsell for their clients or something like that.
Mhm.
When most of the time, like like these like top tech companies are doing is complete overkill for most small to medium sized businesses. So I feel like
Yeah.
production can kind of become like a buzzword or loaded word these days, but
Mhm.
I don't know, maybe I'll get attacked for having that take. We got another question coming in the chat, and this will probably be the last one. We're running a little over, but I want to make sure we get this question. Some teachers worry about students using AI like ChatGPT for assignments, but if an AI can handle the task alone, maybe it's the assignment that needs rethinking. Oh, that's a good question. What's your take?
That's a very good question. I see it there, Rayane. Great question. Yeah, I think about that a lot. Like that's basically, and I have a lot of conversations about that because a lot of people in there, and there's a wave that says you shouldn't let students use ChatGPT because it's doing the homework for them, and I see where they're coming from. So but I feel like the moment a machine can do something for you, uh then you should figure out how to use it for your own purpose, right? And we're not going to lose some skills get lost and some skills get not lost, but slightly replaced. For example, nobody stopped walking because cars exist. I just don't walk 100 kilometers. I take a car, right? I walk shorter distances, and then I know how to drive the car to take me there. So I still do some work. The car does the majority of the work, but I still know how to operate it. And so the skill became from being able to walk really far to knowing how to operate a car. And the next skill when the cars operate themselves is to know where to go, right? There's still some part of the human does, but it's always high level. Calculators, right? We don't forget how to add and subtract, because I'm not going to get a calculator if you ask me how much is 8 plus 4. But if you ask me like a bunch of lot of digits, I get the calculator, right? Even though I could do it. So when calculators came in, then we switched to putting harder math problems that even with a calculator you have to figure something out, right? And so I feel like the next generation is the one that knows how to use ChatGPT and AI models to get better, and we're not going to become stupider. We may lose some skills, like maybe this is sad to hear, but maybe the next generation is not going to be able to write a long essay about something, right? They'll still know how to write stuff like paragraphs and stuff, because you're not going to you still write, but if you can, but they'll be able to write a 500-page book using ChatGPT in a good way. That is a skill that I don't have right now. You know what I mean? Like this is a completely different skill. So homeworks could change to that, right? Like if you say write a 5-paragraph essay about something, the kid's gonna use ChatGPT. But if you say, the assignment is write a 500-page book about something and make sure it's consistent and make sure it flows and it has narrative and that the name of the protagonist is the same on page 1 and on page 500, that's not easy task, right? So that would be like driving the car. So I feel like skills change. But to get one more level philosophical, I would say that I think AI is in the same way that machines do our physical stuff and we pass to the rational realm and we start doing more thinking. Now the machines can do a lot of our rational thinking, and we need to know what level to go to. And I feel like the level to go to is, what is it that AI cannot do? And I think there's a bunch of things that AI cannot do yet, but will be able to do, like maybe more math or more science. And there's the things that I think AI has no chance of doing, and that may be the thing that we need to get more stronger on. I see a pyramid. There's physical stuff, there's rational stuff, and I see at least 2 more levels. One I think of as emotional intelligence, like empathy, emotions regulation, like that kind of stuff does not belong to AI, because AI is a bunch of numbers that take numerical decisions, quantitative decisions. Anything emotion is a qualitative decision. So any kind of emotional intelligence, the soft skills that we call soft skills, we should not call them soft skills. That is impossible for a machine. They can pretend, but they don't make decisions. A machine can sound empathetic, but a hypocritical person can also sound empathetic and pretend that, So it's about taking decisions with qualitative metrics. That's hard for a machine. And another one I think is even higher. Like I see intuition as a thing that we have and the computers don't have. Sometimes we're talking about taking decisions in life. Sometimes you take a decision that you took a while ago without numbers, and then you're trying to make the numbers work. That's somewhere that doesn't. ChatGPT does not have that thing, right? AI does not have that thing. Everything in AI can be tracked down to numbers, and many decisions we take in life are not based on that. So I think at least those 2 things need to become the new skills, the skills that we need to develop, so that we don't get completely replaced. So maybe education will have to focus on those things. I definitely see that if education doesn't start focusing more on emotional intelligence, we're doomed. So I think that kind of stuff may be the next set of skills.
It's just funny that the like engineering majors or like the computer science majors are going to be the ones out of the job, and all the liberal arts students are going to be laughing at them.
That's interesting, right? Yeah. They're going to be the ones asking them, how are you going to make money?
Oh, it's funny. All right. Well, yeah, I think that's we're basically over time, but I think it was a great conversation. Thank you everyone in the audience for the great questions. Thank you so much, Louis, for joining us yet again for the podcast and the great discussion. So next week we'll have another event kind of toward building AI systems in production. We're going to have Rohit from portkey.ai. He's going to be talking about the lessons from building a billion scale AI gateway. So if you're interested in building AI systems that serve, hundreds of thousands of users, I think that's going to be a really interesting talk. And so with that, thank you guys for joining, and we'll see you in the next one. Take care.
Thank you.